extra topics for the ESA examination. So how to crack the gauge with ease regarding to the geotechnical engineering. So first thing first, the importance of the geotechnical engineering in GATE and ESC. I hope you might have gone through all the subjects by now before seeing this video itself. You know how the GATE conduct the examination and you know the pattern of the examination also. I don't need to explain that again. But now, once again, I want to say, out of all the subjects you see in the entire civil engineering, the highest weightage and the most important subject for GATE examination is geotechnical engineering. So if you see the weightage of the geotechnical engineering, around 20% of the questions from the technical section will be appear from the geotechnical engineering itself. You see, in the GATE point of view, so from technical, you are getting 14 to 15 marks out of the 70 marks. You know that the GATE 100 marks, out of that 70 marks is for the technical, and in that 70 you are going to get 14 to 15 marks from the geotech itself, which means 20% of the minimum, that is minimum. If you see the past data from 2013, 14, every year you see, so far and so good, the minimum number of marks they have asked is 13 marks, and they asked like 2 years for 13 marks. But apart from that, you take any year, the minimum number of marks we can expect from geotech is 14 marks. And maximum, it's up our luck, we can get up to the 15 marks. Similarly, in the case of the ESC, so one can expect 15 to 20 questions out of the total 150 questions. So whether it is GATE or ESC, the first and foremost important subject for you is geotechnical engineering. And I don't need to stress out that much, especially for the GATE. So in the case of the GATE, 14 to 15 marks we are going to expect. If you want to study or if you want to do masters in premier institutes like IITs and NITs, or if you want to crack very good GATE rank to enter into the PSUs, the first and foremost subject that you need to give importance is geotechnical engineering. Okay, so let's see what is the syllabus of GATE examination and how I have given this syllabus in a proper pattern and how I have recorded the videos in the ACE online platform. So we conduct the classes for the recorded mode, and we conduct the classes for the online mode, and we conduct the classes for the offline mode. So in all the three platforms we are there to serve you. So now let's see the syllabus. Yes. First thing first, so this was the syllabus that I have taken from the official website. So soil mechanics, and you know that the geotechnical engineering is divided into two parts. One is soil mechanics and other one is the foundation engineering. Soil mechanics is as good as important as the foundation engineering. Okay, so overall around you are going to see total of 18 chapters, and for ESC some extra topics are there, 3 extra topics are there. Okay, so you see here the three-phase system and the phase relationships. The three-phase system and the phase relationships I discuss in chapter number 2, which is known as physical properties and basic relations. The three-phase system and phase relationships. You know that soil consists of two components which are nothing but solids and voids. And these voids may get filled with air or water or both. So the most natural ground soil mass consists of all the three components: solids, water, air. So as three components are there, we call them as a three-phase, and the combined system we call it as a three-phase system. But if you see, if you go to deserts there, or if you go to the arid zones where the water table is very well below the ground level, in those state soil consists of only solids and air. That's a dry state. As two components are there, two-phase system. If you see waterlogged areas or the bed of any river body or any water body, those are completely saturated. which consists of solids and water only. Those are two-phase system. So the analysis of the three-phase system and the analysis of these two-phase system, and in a given soil, how much solids are there, how much water is there, how much air is there, that we are going to learn in the case of the phase relationships by means of void ratio, porosity, degree of saturation, air content, water content, percentage air voids. Then we discuss different type of unit weights. Then we discuss about the specific gravity, and by getting the relation between all those things, the first and foremost equation Sevag, E into SR is equal to W into G, and then gamma equation G plus ESR by 1 plus E into gamma W. So based on those relations, we can find out the volume void ratio relationships, unit phase systems, mixing of two or more soils. These are all topics I discussed in chapter number 2. Next, coming to the index properties, the index properties represents, see basically soil consists of three properties: physical properties, index properties and engineering properties. Physical properties, as the name itself, those are the physical characteristics of the soil mass. And index properties, once you know the soil physical properties, now we have to give a name to the soil mass. We need to identify what type of soil it is and how to classify the name. So to identify and classify the name, we require the index properties. So you might have done the index properties in your laboratory as sieve analysis, hydrometer analysis, Atterberg limit test like liquid limit test, plastic limit test and shrinkage limit test. So these are the tests that you have done in the laboratory to determine the index properties. So I discuss either in offline or online elaborately about these index properties. And once we know the physical properties and index properties, we are going to use ISCS, Indian Soil Classification System, and USCS, Unified Soil Classification System, to classify the soil name that covers in the chapter number 5. But sir, you are saying about chapter number 2, chapter number 4, where is chapter number 1 and chapter number 3? Actually, from the past, from GATE 2021 onwards, so in the syllabus they removed two topics: origin of soils, number 1, number 2, soil structure and clay mineralogy. Actually, you don't need to study those for the GATE examination, but if you don't study those, you cannot understand the concepts clearly, because those are just the basics and it won't take much time. So we need to know how the soil has been originated, what are the various forces acting on the soil, what is the structure of a soil, how the shape of the soil particles looks like, what are the physical properties, means what are some properties like swelling, shrinkage, plasticity, type of minerals. Those I elaborately covered in first and third chapter. For ESC people, you must have to study those. For GATE, you study for the sake of understanding the concept, not for the sake of examination. So those are the first 5 chapters. In the first 5 chapters itself, we'll cover about the 2 major properties, which is nothing but the physical property and index properties. Then from 6th chapter onwards, the engineering properties, which is known as permeability. So permeability, which is a one-dimensional flow. So when there is a flow, what is the permeability and how this permeability will allow the soil, how the permeability will allow the water to pass through it, and for different soils, how you find out the permeability, either by means of experimentally or theoretically, what is Darcy's law and all I explained in chapter number 6. Then seepage through the soil, one-dimensional flow, flow nets, uplift pressure piping, capillarity, this all comes under up to the seepage force, that all comes under in 6th, 7th, 8th, 9th chapter, 4 chapters. But I say all the 4 chapters has to be included. Chapter number 6 permeability, chapter number 7 effective stress, chapter number 8 seepage pressure, chapter number 9 seepage analysis. In these 4 chapters, I will discuss about the permeability and I will discuss about how the seepage passes through the soil, what happens to the soil when seepage passes through it, and how you are going to measure the pressures. As an engineer, we are doctors to the soil mass. So how you are going to diagnose what is the problem to the soil and how you are going to treat it by means of the preventive measures. That all we discuss in the up to seepage force. So that is up to chapter number 9. Next, principle of effective stress, quicksand condition also, this also covers under the chapter number 9. And compaction of soils, one-dimensional consolidation, degree, time rate of consolidation. So chapter number 11, consolidation, chapter number 12, compaction. Elaborately, I discussed everything over there. And coming to the chapter number 13, shear strength. In the shear strength, we discussed about how the shear strength is going to be developed in the soil, and what is the Mohr Coulomb failure envelopes, what is the Mohr Coulomb theories, and what are the stress paths, what are the shear characteristics of the clays and sands. So these covers the first 13 chapters. The soil mechanics covers the first 13 chapters. And you know what? Now let's first go with the soil mechanics, how to prepare. So if you see, in the case of the okay. So in soil mechanics, the most important chapters are permeability, consolidation, shear strength. So these are the important topics. See, I told you the minimum amount of the marks that we can expect from Geotech is how many marks? 14 marks. And out of the 14 marks, from these 3 chapters, you can expect a minimum to minimum of 5 marks. Minimum to minimum of 5 marks. You can expect at least 2 marks questions from these topics. There is no way a gate paper is prepared without having a 2 marks question from these 3 chapters. These 3 chapters we call them as engineering properties. So what are these? These are nothing but the engineering properties. And out of those, and again those topics also, they will be recurred continuously. You see, in permeability, if you see the past 6-7 years, they have asked 4 2 marks questions based on one single concept, that is flow perpendicular to bedding planes, which means when flow happens through the anisotropic soils or layered deposits, how to find out the permeability, how to find out the seepage flow rate. That we will discuss about that topic elaboratively in the next session. So in this session, we will just look into the how to prepare and what are the various chapters you need to give importance. Okay, so this permeability and consolidation. First of all, in the case of the permeability, what type of models one can expect in the permeability? In the case of the permeability, what type of models one can expect? Number 1, flow perpendicular to bedding planes. So the maximum probability of attaining a question, 2 marks question from this chapter is this one, flow perpendicular to bedding planes. So what happens when flow is perpendicular to the bedding planes in the case of in stratified deposits? So if you remember, when the flow is perpendicular to the bedding plane, the same flow rate will pass from one soil to the other soil, and the head loss required to cause will be more. By using that, you are going to use a Darcy's law. What is Darcy's law? Darcy's law is nothing but Q is equals to KIA. By using that, we are going to find out some characteristics, and we are going to find out the permeability. That permeability KY is equals to Z1 plus Z2 by so on, Z1 by K1 plus Z2 by K2. If they ask about how to find out the permeability perpendicular to the bedding plane, but if they ask about something different, then you have some logics. And anyways, don't worry, I am going to discuss about the topic elaboratively in the tomorrow's session. But my point of view here is, from the permeability topic, you can expect a 2 marks question from this topic. The flow perpendicular to the bedding planes. Apart from this, then they can ask based on the Darcy's law. They can ask the questions based on the Darcy's law. So Q is equals to KIA. So what about, for suppose, what they say is, a permeable soil is confined between two impermeable soils. A permeable soil is confined between two impermeable soils. And now you see, some mode of question I can expect. So I'll give you a permeable soil. Let's take this as a sand, and let's take this as a clay, and this is also a clay. I am allowing the flow through the permeable layer, sand. Now I will say that by keeping the piezometers at 2 points A and B. So you know that whenever there is a flow, there is a head loss. Whenever there is a flow, there is a head loss. So now here the water level rises to this height. As there is a head loss, so the distance covered by these two, I will give you some length. So I will provide you some length, and the distance, the difference between these two water levels is nothing but h. So now what I am going to ask you in this question is, what is the flow rate passing through the soil? What is the flow rate passing through the soil? What is the flow rate passing through the soil? How you find out the flow rate? If I know the permeability K, so you can find out Q is equals to KIA. If you know the thickness of the soil element, you can find out the area. What is I? Hydraulic gradient, which is H by L, and what is K? Quotient of the permeability. Either you can expect directly this question, or I can expect a question as the water, the time taken by the water, the time taken by the water. So I am going to ask you the time taken by the water to travel from A to B, to travel from A to B. So if I ask you the time, you see the time depends upon the seepage, actual velocity. You know the seepage velocity, right? So what is the seepage velocity? Seepage velocity is nothing but discharge velocity by porosity. So in the same question, instead of asking you the flow rate, what I'll ask you is, if I keep a piezometers at point A and B, now what is the time required for the water to travel between A to B over the length? This is inclined soil mass, the seepage is going to be inclined seepage, the length is going to be inclined length. Now I have to use the seepage velocity. What is the seepage velocity? See, time, right? Distance by time. So now I require the time is equals to V by N into L. So what is V? Ki by N into L. What is N? Porosity. Look, if they ask about the time required to travel the seepage, you must have to use the seepage velocity only. For finding the flow rate, you can use both seepage velocity or you can use a discharge velocity, because Q is equals to either A into V or area of voids into seepage velocity. So the product of these two must be same, whether you use seepage velocity, whether you use the Darcian velocity. If you use seepage velocity, you must have to use the area of voids. If you use the Darcian velocity, you must have to use the total area. But the product is going to be same. But if I ask you the time required to travel the particle, you must have to use the seepage velocity. And what is seepage velocity? Discharge velocity by porosity. Once you find out the seepage velocity, I'll give you the porosity. So Darcian velocity is nothing but whom? Ki, right? I know K and I know I, H by L. I know N and I know the L value. I can find out the time required for the water particle to travel. So these are the two type of models we can expect. One is the flow perpendicular bedding planes, and I'm not going to discuss much because I want to discuss that elaboratively. We'll solve some gate problems. Another one is finding the flow rate passing through the soil. Finding the flow rate passing through the soil, and how to find out the time required for the water to travel from one place to other place. This is one. So second model, this is a second model, and third model, third model one can expect is finding the effective stresses. Finding the effective stresses in the case of the seepage. So this covers chapter number 7, 8, 9. This covers chapter number 7, 8, 9. Okay, so they will give you the soil element. They will give you the soil element, and this is a soil. In order to occur the flow, you know that flow always takes place from higher energy level to lower energy level. So let's say I keep a water table on the top of it, and I provide some tap at the bottom. I provide some tap at the bottom. Okay. So let's say the height of the water is HW and total depth of the soil is some Z. Okay. Now if I open the tap, that will create a downward seepage, right? If I open the tap, obviously the flow will pass through the soil. So that is going to be the downward seepage. Now the type of questions that you can expect is, they will give you the flow medium. They will give you the difference between the water levels. Let's say the water level is somewhere over here. After opening the tap, the water level is somewhere over here. Now I want to find out the effective stress at some section XX. At some section XX. Okay. So now if I want to find out this, first thing first, what is the type of seepage? Flow occurs from higher water level to the lower water level. So higher water level to the lower water level, and this is a downward seepage. So for this downward seepage, you can find out the effective stress directly. You take that plane XX. You know that above this HW water, no solids are there, no effective stress. And let's take the depth up to here is a ZX. Okay. And in this ZX portion, soil is completely submerged. Due to submergence, gamma dash into ZX. That is the effective stress. In the HW, no solids, no effective stress. In this ZX, soil is completely submerged. So keep your palm, you can feel gamma dash into ZX. Apart from that, due to the difference in the water levels, flow will take place or not. From this point to this point, there must be some seepage. It must have exerted some pressure. And by the time it reaches over here to over the ZX, this water has spent some energy. And what is that energy that it has spent? What is the pressure? Gamma W into Hx. So what is the Hx, sir? That Hx is nothing but head loss up to x. Head loss up to x. How can I find out the head loss up to x, sir? You know that I value, what is I? Literally I is nothing but H by L. So whatever the total difference in the water levels is nothing but H, and total depth is a Z. So H by Z. H by Z. Okay. So I is equals to H by Z. And Hx is equals to I into length up to the section. So here what is the length up to the section? The length up to the section is nothing but Zx, right? In the case of the downward seepage. So as simple as that, I can revise, I can divide these two. Now what is the effective stress here? The effective stress will be submerged pressure acting downward, and as it is a seepage, the downward seepage pressure also acts downward. So gamma dash into Zx plus gamma W into Hx. Similarly, if I would have created for the upward seepage, so in the case of the upward seepage, effective stress is same upward seepage. The submerged pressure is going to be gamma dash into Zx only. But upward seepage, it is upward direction. Along the direction, whatever the seepage pressure, Hs of x. So in this case, effective stress is gamma dash into Zx minus gamma W into Hs of x. So either you get a question from the flow perpendicular to bedding planes, or They will ask you to find out the flow rate passing through the soil, or they will ask you the time required to travel, or they will create a seepage like this and they will ask you the effective stress. So this is a downward seepage case and this is a upward seepage case. These logics have been clearly mentioned and how to apply with examples in the online live sessions and recorded mode, which is ACE online platform. So these topics we elaboratively discuss, and you see, no matter whatever the question, within a minute you can solve this type by following the logics. So these are the things that you can expect from the chapters of permeability and seepage. And now coming to the consolidation. So in the case of the consolidation chapter is divided into two parts. If you see the syllabus also, in the syllabus, the consolidation is one-dimensional consolidation, time rate of consolidation. So one-dimensional consolidation, first of all, what is meant by consolidation? Consolidation is nothing but process of expulsion of water. To reduce the volume. So the process of reduction in volume by expulsion of water is known as consolidation. So we divide that total into two parts. One is, what is the maximum settlement that can one expect? When water goes out, obviously one dimensional consolidation means volume decreases in vertical direction only. You don't see any change in the lateral direction, we neglect that. So what is the, as water goes out, soil will compress. What is the maximum compression? Maximum settlement. So one model that you can expect over there from the consolidation. Now from consolidation topic. Number one, finding ultimate settlement. So I have given you some equations. There are a lot of equations. SF is equals to mv into h into delta sigma dash. SF is equals to AV by 1 plus E naught into h into delta sigma dash. SF is equals to CC by 1 plus E naught into h into log base 10 sigma naught dash plus delta sigma dash by sigma naught dash. But out of these equations, the most commonly used equation means for engineering calculations we prefer CC, because MV and AV, they are not going to be constants. So these are not going to be constant, this is the constant. In examination, until or unless they mention MV constant or AV constant, we don't use the SF with respect to MV AV. If nothing is mentioned, you always prefer the SF equation. This is one way they can ask you the settlement, ultimate settlement. But in order to understand this ultimate settlement, you need to know the gathering information, what happens in the consolidation when time 0, initially entire load will be taken by water and develops as excess pore water pressure. Now as water goes out, the excess pressure developed in the soil will decrease. Then who will take? That decreased pressure will be taken by the solids. So slowly, first load will be taken by whom? Water. Water goes out, then that load will be taken by whom? Solid. When the load acting on the solid keep on increases, effective stress keep on increases. Soil will undergo compression. At the end, once the water going out stops, that is known as end of consolidation. So this is one way to find out the ultimate settlement. And second part is time rate of settlement. What is the meaning of this time rate of settlement, sir? So if I give you a building constructed on some compressible layer, settles some 50 mm in 4 years. What will be the settlement at the end of the 8 years? So I gave you for 4 years 50 mm. Then for 8 years, which means next 4 years, how much? First 4 years 50 mm, next 4 years also going to be 50 mm. So at the end of the 8 years, it is 100 mm. Is it? No. you know, with the time settlement increase, but rate of settlement decreases. What is the meaning of this? For the first 4 years 50 mm, from 4 to 8 years settlement will increases, but it will not increases just like 50. In the next 4 to 8 years, in the 4 years span, it might increase around 20 or 30. So by the end of the 8 years, it will not be 100, because initially more water goes out, more volume decrease, compressibility is also going to be decreases, permeability also decreases. Later on, amount of water going out will keep on decreases. So volume reduction will decrease. In the first 4 years, settlement happens quickly to 50 mm. In the next 4 years, it will not be 50, it might be 30. And you take next further 4 years, which means 0 to 4, 50, 4 to 8, I am saying 30. Now 8 to 12, you say it may be some 15 or 20. So as the time increases, the rate at which the settlement occurs keep on decreases. So for finding that, we have two relations. One is time factor, TV equals to CV into T by D square. Another one is a degree of consolidation, S by SF into 100%. So by using these, we get the relationships. So where as long as U less than or equals to 60%, TV equals to pi by 4 U square. And when U greater than 60%, TV equals to 1.781 minus 0.933 log base 10 100 minus U in terms of percentage. 100 minus U in terms of percentage. So by getting the relation between these, you know that when U1 comma U2 are less than or equals to 60%, when U1 comma U2 less than or equals to 60%, T is directly proportional to the S square. Else TV directly proportional to the T. So by framing these relations using this, I can find out the rate of settlement. I can find out the settlement required for a given time. I can find out the time required for the settlement also. So the consolidation chapter is broadly described into these two parts. Apart from that, we discussed about the cyclic loading, what happens when you load and unload and reload to the soil mass, that comes as a cyclic loading. What is meant by NCC, what is meant by OCC, and what is meant by consolidation test. So, but eventually the questions that can turn up from the consolidation is, these are the models. Okay. Now, similarly, yeah. So that's about the consolidation. Next, coming to the shear strength. In the shear strength, the most important topic is a triaxial test. Again, 70% of the previous GATE and DSA questions has appeared from the shear strength topic. In shear strength topic is from the triaxial test, unconfined compression test and its results. So in the case of the shear strength topic, okay, so let me have some water.
Wise test and full length test. Then for mains preparation, I solved question banks which were given to me as a part of mains postal program from ACE Online. And then last but not the least, for interview preparation, I followed the interview guidance material which was given to me as a part of ACE Online's interview guidance program. Thank you. My name is Karthikeya Kaushik and I have secured All India Rank 1 in UPSC Engineering Services Examination 2021 from Civil Engineering discipline. For prelims preparation, I took online test series from ACE Online platform and used to regularly solve their subject-wise test and full-length test. Then for mains preparation, I solved question banks which were given to me as a part of mains postal program from ACE Online. And then last but not the least, for interview preparation, I followed the interview guidance material which was given to me as a part of ACE Online's interview guidance program. Thank you. My name is Kartikeya Kaushik and I have secured All India Rank 1 in UPSC Engineering Services Examination 2021 from Civil Engineering discipline. For prelims preparation, I took online test series from ACE Online platform and used to regularly solve their subject-wise test and full-length test. Then for mains preparation, I solved question banks which were given to me as a part of mains postal program from ACE Online. And then last but not the least, for interview preparation, I followed the interview guidance material which was given to me as a part of ACE Online's interview guidance program. Thank you.
Now, come to the shear strength. So, from the shear strength chapter, more number of questions one can expect from the triaxial test. So, apart from that, first what are the equations that we have is S is equals to C plus sigma into tan phi. So, this equation is used to determine the shear strength, and there is one more equation, plastic equilibrium equation, sigma 1 is equals to sigma 3 tan square alpha f plus 2c tan alpha f. Okay. So, if you want to find out the stresses acting on any element, if you know the major principal stress and minor principal stress, if you want to find out stress acting on any element, normal stress and then shear stress, you can find out the values directly. So, the sigma 1 and sigma 3 are nothing but major principal stress and minor principal stress. To reduce the complexity of the stresses, we assume the shear stress acting on a horizontal plane and vertical plane as 0, such that if shear stresses are 0, we call them as principal planes. And sigma 1 is major principal stress, sigma 3 is minor principal stress. So, if you know this, you can find out the normal stress acting on this plane as sigma 1 plus sigma 3 by 2 plus sigma 1 minus sigma 3 by 2 cos 2 alpha, where alpha is angle made by this plane with respect to the major principal plane. If this is major principal stress and this is major principal plane. And shear stress tau is equals to sigma 1 minus sigma 3 by 2 sin 2 alpha. So, these are the equations that you are going to see in the shear strength, but more importantly the applications are required. The applications of these equations are in the case of the triaxial test. So, in triaxial test, from the applications of the CD test, UU test and CU test. So, we discuss about 3 tests, CD, UU, CU. The CD test is consolidated drain test. In triaxial test, we do the test in 2 stages. One is consolidation stage, another one is the shearing stage. First we apply one pressure known as cell pressure, and then we apply some additional pressure known as a deviatoric stress to cause the failure. So, once we know those, then the consolidated drain test, that is a completely drain test. This test is suitable to find out that to check the stability of the foundation after many years. And UU test, unconsolidated undrained test. Unconsolidated undrained test. This test is used to check the stability immediately after the construction. Why, sir? Unconsolidated undrained means we did not allow the water to go out. Just next after you construct the structure, water will not go out immediately. So, there to check stability we use UU test. CD test means we allow the water completely to go out. That will happen after many years of time. So, to check stability in long term, CD test, short term, UU test, and in between after some 10 years you go for the CU test. So, the results of these tests are very important for the examination. So, what is the results, sir? The results are CD comma CU test on NCC soil, normally consolidated clays. Whether it's a consolidated drained test or consolidated undrained test, the failure envelope passes through the origin. When the failure envelope passes through the origin, the cohesion is going to be 0. And how to find out the angle of internal friction, sir? Phi is sine inverse of sigma 1 minus sigma 3 by sigma 1 plus sigma 3. Sigma 1 minus sigma 3 by sigma 1 plus sigma 3. This is CU comma CD test on NCC. Now, similarly, if you do UU test on any soil, phi is equals to 0 degrees. When phi is equals to 0 degrees, the failure envelope is going to be horizontal. So the failure envelope looks like this, phi 0 degrees. And if this is the Mohr circle, then what is the Cu value? The C value is simply the tau maximum or half of the deviatoric stress, because this is sigma 3 and this is sigma 1, the difference is nothing but the deviatoric stress. So the C value is tau maximum or sigma d by 2. So that value is nothing but sigma 1 minus sigma 3 by 2. Okay. So if you observe, based on these results itself, you can go through the previous gate questions, previous ESC questions. I am telling you 70% of the numericals will fall in this itself. So two equations, basic equations to determine shear strength and to determine the C comma phi. These relations are also attained by using this equation, we call it as a plastic equilibrium condition. And apart from that, if they give any element to find out the normal stress and shear stress, you can find it out. If it is a failure plane, then tau becomes tau f, alpha becomes alpha f. And based on the triaxial test, these are the results. So CD test, CU test, C0. Similarly, they can ask you, instead of CD test, CU test, they can ask you a triaxial test conducted on dry sand. Dry sand, sand, C0. When C0, how to find out phi? A triaxial test conducted on pure clay, phi 0. When phi 0, what is C value? These are the two things that you are going to play. Shear strength is a very lengthy chapter. And out of that lengthy chapter, if you want to score very good marks, this is the topic. Apart from this, they can ask you the unconfined compression test, where compressive strength of the soil, QU is equals to 2 times of the shear strength. That's it. And in recent times, they are asking about the stress paths also. Stress path is nothing but locus of the change in the state of stresses. By taking the maximum shear stress points, so that's a different topic. But mostly they will ask about this. In the case of the ESC point of view, they will ask about these topics, and they will ask about the stress path, they will ask about the questions from the test also. So whatever the discussion I have made now, you see here, from the permeability topic, what are the questions that I can ask? Layer deposits, finding the flow rate, finding the time required for the water to travel. And I am just discussing everything in a one single frame here itself. So how to find out the effective stresses, and how to find out the effective stress if there is a seepage. If it is a downward seepage, the logic, this is the logic. If it is upward seepage, the logic, this is the logic. Okay. And how to find out effective stress? Total stress minus pore water pressure. Keep your palm, find out the total stress. Keep the piezometer, find out the pore water pressure. This sounds good for chapter number 6, 7, 8, 9. And then I discussed about the consolidation. So consolidation, either by means of the time rate of the consolidation or by means of the ultimate consolidation, and triaxial test in the case of the shear strength. So these are the major topics that we can expect in the soil mechanics. Whatever the topics I have mentioned now, you can check through the previous gate. You can get at least 5 to 6 marks from these 3 chapters itself. Such an important chapters these are. 5 to 6 marks. Sir, apart from that, now let's go back to the syllabus once again. So apart from that, you may expect 1 or 2 marks from the phase relationships, index properties and IS classification systems. So around 1 or 2 marks. So overall the soil mechanics comprises of around 7 to 8 marks. 7 to 8 marks from the soil mechanics. Out of the 7 to 8 marks, you can expect minimum 5 marks from consolidation, shear strength and permeability chapters. That's the beauty of the soil mechanics. So don't forget that. So while you are preparing, you prepare in such a way, you keep the gate material with you, you keep the ESC material with you, you see from which topic they are asking a more number of questions, you write those. Though it may take some time for you, but it's better you write those here itself, now itself. Still you are able to crack, you will be able to crack the gate examination. And I am a student of the same ACE Engineering Academy. I did my masters from the IIT Hyderabad and I got all India gate rank of 600. Why I am saying this one is, you know what, today is on August 1st and I started my preparation on August 20th and I took 4 months, August to January, and I cracked all India rank 600. Okay, so if even I can do, if I do, that's a high possibility that you can do also. So if you haven't started your preparation yet, don't worry, do start. But do make a proper pattern, do make a proper schedule, do make a proper way to analyze, to understand, to prepare. Don't just blindly follow the things everywhere. Just because you love the subject of the others, don't go. You have to love now based on its weightage. So I say, you have to love the geotechnical engineering no matter what. Okay, so that's about the soil mechanics. And I hope you understood what are the major topics that, that can be asked. So apart from that, so three-phase system and phase relationships, they can be asking basic questions. So void ratio, dry density and all. And in index properties, they can ask you from the Atterberg limits. In index properties, sieve analysis is there, wet sieve analysis is there, relative density is there, and Atterberg limits are there. So in the Atterberg limits, there is a chart known as consistency chart. They can ask you that, but the probability is less. But these are the 3 chapters, okay? Next, coming to the foundation engineering. So from 14th chapter onwards, foundation engineering, earth pressure theories, stability of slopes, shallow foundations, deep foundations, soil exploration. These are the 5 topics: earth pressure theories, stability of slopes, shallow foundations, deep foundations and soil exploration. So subsurface investigations, drilling borehole, sampling, plate load test, standard penetration test and cone penetration test, these all are covers under soil exploration topic. Earth pressure theories, Rankine and Coulomb, those are covers under chapter number 14, earth pressure theories. Stability of the slopes, which is nothing but the chapter number 15, stability of slopes. In that there are 2 types of slopes, finite slopes are there, infinite slopes are there. We have to do the analysis separately. For infinite slopes, the analysis is like translation failure. For the finite slopes, the analysis is based on the rotational failure. Bishop's method and stress distribution in the soils, actually this is the chapter number 10, which should cover in the soil mechanics. Stress distribution, in that stress distribution we discussed about the Bosni's theory, Westergaard's theory, Newmark's method, Newmark's chart and approximation method, pressure bulbs also. Now coming to the chapter number 16, shallow foundations. The most important method is Terzaghi and Meyerhoff's baying capacity theories, effect of water table, combined and draft footing, contact pressure, settlement analysis in sand and clays. Anyways, this settlement analysis in sands and clays will be covered in the consolidation chapter. Now, in the case of the bearing capacity, which is nothing but shallow foundations, we mainly discuss about how to design the foundation, design of the shallow foundations, how to find out width, depth, factor of safety and loads. And then deep foundation. So deep foundation means pile foundation. In the pile foundation, to determine the load capacity of the pile, we have dynamic formulae, we have static formulae, we have pile load tests. So dynamic formulae, static formulae, axial load capacity means vertical load capacity. In sands and clays, pile load test. Now you see this topic, pile under lateral loading. This is a new topic which has been implemented from GATE 2021 onwards. But Fortunately or unfortunately, there was no question asked so far. But anyways, so this is a new topic one. The new topic, the additional topic is piles under lateral loading. And pile group efficiency, pile settlement, negative skin friction. This all comes under chapter number 17. So chapter number 18, soil exploration. 14, earth pressure theories. 15, stability of slopes. 16, shallow foundation. 17, pile foundations. 18 is the soil exploration. This is about the GATE syllabus. Apart from this, some extra syllabus is there for the ESC. For the ESC, the extra syllabus is principles of ground modification techniques. Next, geosynthetics, and then caissons, Okay, so principles of the ground modification techniques, geosynthetics, and caissons. These are the 3 extra topics for the ESC. Okay, now let's see what are the important topics that can be covered in the case of the foundation engineering also. From foundation engineering, you can expect a 2 marks question from chapter number 14 and 15 alternate years. There is a possibility they can ask 2 marks question from both the chapters at single year, but the most probability is either earth pressure theories or stability of slopes. Either earth pressure theories or stability of slopes. Okay, so first in the case of the earth pressure theories, what can we expect? In earth pressure theory, what is earth pressure? Pressure exerted by the soil on the wall. Based on the wall movement, we have 3 cases: at rest condition, active condition, passive condition. If the wall is restrained from yielding, we can call it as at rest condition. If wall is moving away from the backfill, we call it as a active state. Wall moving towards backfill, we call it as a passive state. Out of those, the most commonly and the most easily occurred failure is active state. So in the case of the earth pressure theories, we discuss about the 2 theories, Rankine's theory and Coulomb's theory. And our analysis, our examination point of view, we require the Rankine's theory only. And based on the Rankine's theory, we saw soil is dry and cohesionless, and we see what happens when there is a surcharge, we see what is the effect of the water table, we see what is a layer deposit, and we see what happens if there is a cohesion. Okay, so the most frequently asked question from this topic is about the layered deposits. So if this is a retaining wall, if the retaining wall is supporting a layer deposits having 2 different soils, C2, Phi2, Gamma 2. So they can ask you what is the maximum force acting on the wall. They can ask you what is the maximum force acting on the wall before the formation of the tension crack. So because of the cohesion, you know, when there is a cohesion, the active earth pressure is Ka into sigma V minus 2C root Ka. Ka into sigma V minus 2C root Ka. So if there is a cohesion, definitely there is a formation of the tension crack. What you can expect the questions is, what is the active force before formation of crack? Before formation of crack, and what is the active force after formation of crack, and what is the active force after filling crack with water. So when there is a layered deposit, you have to first draw the pressure distribution. So while you are drawing the pressure distribution, one should be aware at the interface you have to take just above and just below. Just above you have to use phi1 Ka1, just below you have to use Ka2. And the vertical stress acting on this interface just above and just below both are same. So we have elaborately discussed those problems. You can go through the ACE online platform, you can download the app and you can register. Okay. So these are the topics that we can see from the earth pressure theories. And apart from that, you see, I'm discussing about what are the major topics that they used to ask, not every topic, okay. Now, so if I go for the stability of slopes, again, two topics they used to ask mostly. One is infinite slopes, and second one is the Taylor stability chart from the finite slopes. Okay, so for the infinite slopes, what is the factor of safety? C plus sigma into tan phi by tau. So factor of safety F is equals to C plus gamma z cos square I tan phi by gamma z cos I sin I. Okay. So if there is a cohesionless soil, just keep C0, gamma z gets cancelled, cos gets cancelled, and one cos will come to the denominator, that's going to be sin I by cos I, tan I. So if it is a cohesionless deposit, for dry, tan phi by tan I, tan phi by tan I. So if it is a cohesionless deposit, so C value is equals to 0. If it is a dry condition, factor of safety F is equals to tan phi by tan I, tan phi by tan I. Okay, and if it is a submerged condition, factor of safety F is equals to tan phi dash by tan I, tan phi dash by tan I. And if it is a seepage parallel to slope, then the factor of safety goes as, in the numerator you have to use gamma dash, in the denominator you have to use gamma sat. In the numerator you have to use gamma dash, in the denominator you have to use gamma sat. So this case is for the seepage. In the numerator gamma dash, in the denominator gamma sat. And if I ask you for the cohesionless soil, the C value is equals to 0. When C is equals to 0, factor of safety is nothing but gamma dash by gamma sat into tan phi dash by tan I, tan phi dash by tan I. So these are the topics they used to cover mostly. And in the case of the finite slopes, they used to ask about the stability number for finite slopes. So factor of safety with respect to cohesion, C by Sn into gamma into H. And apart from that, they will ask about the basic functionality of the factor of safeties. They will give you some slope as a finite slope. You know, the finite slope is going to be fails by means of the rotational failures. So you know, sometimes they will give you just simply the failure surface, and they will give you the weight and all, they will give you the distance. You need to find out the factor of safety. So how to find out the factor of safety here? That factor of safety, see, the failure caused by means of rotation, right? So this rotation will be resisted by the resisting moment, which is anti-clockwise, by driving moment. So that resisting moment will always be Fr into R, and causing moment will be W into X. Now we have to work out how to find out the resisting force. Resisting force is nothing but shear strength. So factor of safety is nothing but shear strength into surface area into R by W into X. Whoever the resisting, that is the numerator. Whoever the causing, that is denominator. If they give weight is responsible, W into X. If they give tangential force is responsible for the failure, then you have to take the tangential force into perpendicular distance. So this chapter is more of generality, better later means a more of generalized thing instead of remembering the formulae. So for the Taylor stability chart, you can use this equation. This is about the chapter number 14 and chapter number 15. And there comes the foundations. So in the case of the foundation, the one equation that plays everywhere, that role is in bearing capacity, that equation is nothing but equation given by the Terzaghi. You know that when you are going to construct a foundation, you should make sure whatever the gross pressure coming from the structure, gross pressure means the total pressure. So whatever the gross pressure coming from the structure, this gross pressure must be less than or equals to safe bearing capacity. The gross pressure must be less than or equals to safe bearing capacity. So in order to design, the design means finding the width, finding the depth, finding the factor of safety, depth, width, and what is the gross load or what is the net load. So in order to design all these things, all these parameters, we require the design condition. The design condition, whatever the total gross pressure, it must not exceed the safe bearing capacity. So for that, first we need to work out the safe bearing capacity. So see, in the case of the bearing capacity topic, this is the main important one, okay. And how to find out the safe bearing capacity? That safe bearing capacity can be found out as a net safe plus gamma d, and net safe can be found out as a net ultimate by factor of safety. Net ultimate can be found out as a ultimate minus a self weight. So overall, if you want to design, you need to find out the ultimate bearing capacity. For finding the ultimate bearing capacity, we have various theories. Rankine's theory, Terzaghi's theory, Prandtl's theory, Meyerhoff's theory, Weissig's theory, IS method, Skempton's theory. But we don't require all these methodologies. What we do is Terzaghi. So basically whatever the questions they give, mostly they will give you about the Terzaghi only, okay. So now let's see that equation. So what type of questions that you can expect in the case of the bearing capacity is design. They will ask you the width. They will ask you, for example, I'll say a square footing is rested at a depth of 1 meter below the ground level. Square footing is rested at a depth of 1 meter below the ground level. Now, in order to apply a gross pressure of some 200 kilopascals through the base of footing on a cohesionless sand deposit, cohesionless soil, the width of the foundation should be. So I am asking about the width. I will give you the factor of safety, I will give you the load, I will give you the depth. You have to use these conditions, you need to find out the width. So for finding that, you require the ultimate bearing capacity, na? So the ultimate bearing capacity QU is equals to CNC plus gamma DNQ plus 0.5 gamma B N gamma. Okay. Now you see, this equation was given by Terzaghi for long strip footing. If it is a square footing, just simply square 1.3 and shape factor will be 0.4. If it is a circular footing, 1.3 and this is a 0.3. The remaining is same for the square 1.3 CNC, 0.4 gamma B N gamma. For circle 1.3 CNC, 0.3 gamma B N gamma. While you are discussing about the bearing capacity, you need to keep 5 things in your mind. First one, type of footing, whether it is strip or isolated. In the isolated, square, circle, rectangle. Number 2, type of soil, whether it is a cohesive deposit, cohesionless deposit or C5 deposit. Number 3, location of water table, whether the water table is well below the base of footing or at footing level or at ground level. Number 4, type of failure, general shear failure or local shear failure, because in shallow foundations we have two type of failures, GSF and LSF. As long as the phi value is more than 28 degrees, you can consider as GSF. If phi value less than 28 degrees, we have to consider it as a LSF. So now, first I explained the type of the footing, and in the case of the clay, if they give the clay, in the case of the clay, NC that depends upon the base, whether it is smooth, it is a smooth 5.14, if it is a rough 5.7. NQ is equals to 1 and N gamma equals to 0. If you substitute, the net ultimate bearing capacity is CNC. So cute and sweet equation. Just simply substitute N gamma 0, width effect gone, NQ 1, then gamma D. This is ultimate. But what is net ultimate? Exclude the self weight. If you remove that gamma D, what else remaining? CNC. So you must have to remember this. And I am telling you, for ESC they will be asking more number of questions on basis on the clay soils itself. Okay. So we have seen the effect of the shape, effect of the soil. If the phi value is less than 28 degrees, then failure is nothing but local shear failure, where the failure happens locally, where the actual C comma phi are not going to mobilize. The mobilized values will be less than the C comma phi. So there I have to use C as a Cm and phi as phi m, then NC become NC dash, NQ dash and N gamma dash. In the same equation, I consider the type of failure also. I consider the shape also. Now, if I consider the type of soil also, 3 done. 4th one, effect of water table. If water table is well below, no need of the effect of the water table. If the water table is at the footing level, whatever the width effect is there, so with a depth of B, that will be under submergence. If the water table is at footing level, I keep the width effect as gamma dash. If the water table is at footing level, I keep the surcharge effect also gamma dash. If the water table is in between, you know how to find out the effective stresses. Same equation, effect of the water table, 4 done. And last one, so we have seen the type of soil and the shape of the footing, and we have seen the we have seen the type of failure, and we have seen the effect of the water table. So we covered everything. And now if I give you eccentrically loaded also, you can cover over here. Instead of giving the concentrated load, if I give you the eccentrically loaded area, so for eccentrically loaded area, for example, if this is a footing of width length L, if this is a concentrated load, if you want to make that, if you want to use this theories, you should make that point as equivalent concentrated load. That can be done by reducing the base dimensions from B dash to, means B to B dash and L to L dash. Then in this equation, it will be changes as a B dash. So effect of water table, effect of type of soil, shape and type of failure, and we have seen the concentrated load are effective, means concentrated load are eccentrically loaded. See, this is the major topic that can be covered. Okay. So, but for that you need to understand the pressures clearly. What is ultimate bearing capacity, what is net ultimate, what is net safe, what is safe, what is net pressure, what is the gross pressure. There is nothing in this chapter except this equation. I played with this equation only. Apart from that, there is a plate load test. In the plate load test, they can ask you the questions. So based on in ESC, they can ask you what is initial shearing pressure, what is the thickness, what is the plate size, what is the load you apply, how the graphs are going to be plotted, and what are the corrections with respect to the settlement, what are the allowable settlements. This is about chapter number 16, bearing capacity. Hope you understood this. Yes, with one equation, lot of modifications. Next, chapter number 17, pile foundations. So in the case of the pile foundations, it's all about how the load is going to be transferred. So Now whatever the pile that we are going to install, whether you drive or whether you dig a borehole, the ultimate load that the pile can carry depends upon resistance offered by the sides, skin friction, average skin friction, and base resistance, which is nothing but the bearing capacity. So we have two formulas, static formulae and dynamic formulae. As per static formulae, Qu is equals to base resistance plus side resistance. This base resistance is nothing but ultimate bearing capacity into area at base. Side resistance, average skin friction into surface area. If it is a clay, the bearing capacity is nothing but simply cohesion effect C into Nc, where Nc is equals to 9. And if it is a skin friction, Qs is nothing but whatever the mobilized adhesion, alpha into C bar, where C bar is the average cohesion along the length. That's about the clays. And in the case of the sands, the QB is nothing but vertical stress, effective vertical stress into NQ. And you know, in the case of the sand, the vertical stress keep on increases up to certain depth only. Then later on, it remains constant. Whatever the depth up to which it is going to be varies, this is nothing but the critical length of the pile. And what about here? This is gamma dash DC. This is gamma dash DC. Okay. So QB is nothing but the vertical stress, effective vertical stress into NQ, whereas QS is K into average vertical stresses into tan delta. So these are the details. To find out the ultimate load carrying capacity of an individual pile, based on the soil is clay and based on the soil is sand. The most number of questions that has been asked from this is on the clays only, and they will be asking a questions on a group action instead of the single or individual pile. So if you see the group action, so you know that group action, so in the case of the group action, you know whatever the group that you take, if it consists of some four piles, let's say, this pile foundation may fail by punching shear failure, but that punching shear failure might happen if any one of these pile fail individually, then obviously one by one next pile also will fail, or the total pile group can fail by means of a block. So there are two mode of failures. One is individual mode of failure and other one is a block mode of failure. I should not allow any of those two failures. So first of all, we need to find out what is the maximum load that the group can take. Maximum load that the group can take if they are acting as individual. That is simply whatever the number of piles n into load carrying capacity of the each pile Qi. So if it is a clay, you know this is the equation for the clays. If it is a sand, these are the equation. Find it out for each pile, multiply with the n. This is the load carrying capacity of the group acting as an individual. If the load of this group exceeds this value, soil means a pile will fail by as an individual failure. But if you look for the block, the load carrying capacity of the pile acting as a single block, so if it is going to act as a block, then the whole block you have to take, the areas will be changing. Then what is the value? QB into AB plus QS into AS. Then in the case of the block, the area is nothing but B0, L0. Let's take the width as B0 and L0. And surface area is nothing but 2 times of B0 plus L0 into L. And while you are solving this question in the case of the clays, we have to assume the adhesion factor as 1. We will find out the load carrying capacity of the group acting as individual and acting as a block. If the load exceeds individual, pile fail by means of the individual failure. If it exceeds QG of B, block. I don't want anyone to be happen. So whatever the QG load carrying capacity is smaller of both. So this is the static formula that we apply to determine the ultimate load carrying capacity of an individual pile and of a group pile. If you know the individual pile, the same formula we apply over here. We don't apply any new formula. And apart from this, there is a dynamic formula based on the engineering news and Hillis formula. Those things will be asked in the case of ESC rather than in the case of the GATE. And in the recent times, they were asking more number of questions on under-removed piles and the tension piles. Tension piles is nothing but the uplift pile. So far and so good, we discussed about the compression pile. A compression pile means this is the load and the resistance will be from the base and sides, QS. This is a compression pile. But if I give you the tension pile is mainly constructed to resist the structure from the uplift. So if the load is like this, then in order to pull this one, the maximum load is applying is QU. And now the resistance mainly is due to the self weight of the pile plus the skin frictional resistance. So here in the case of the carrying capacity of the tension pile, here it is nothing but self weight of the pile plus QS. So you see the difference. Here this is a compression load, that load will be taken by the soil and offers by resistance. And here tension pile, the structure tries to lift up. In order to pull it down, you have to see the skin friction and you need to depend on the weight of the pile. And there is one more concept known as the under-removed pile, which we have covered elaboratively. So in the recent times, they are asking more number of questions regarding to the tension pile and under-removed piles. And in general, you can expect a 2 marks question from the topics of the group action or individual action. And 1 mark question you can expect from the engineering, in the dynamic formula. Okay, so this is about the pile foundations, and every year in the past 5 to 6 years, every year they are asking at least 1 more question from the pile foundations. So they are giving more importance towards the pile foundations and shallow foundations. As I told you, in the first soil mechanics, in soil mechanics, you can expect from these 3 chapters as 5 to 6 marks. In the foundation engineering, from the foundations itself, which means bearing capacity and deep foundation, you can expect a minimum 3 to 4 marks. Minimum 3 to 4 marks there itself. You can say 4 marks also. And from earth pressure theory, stability of slopes, 2 marks. Any one of those, 2 marks. And shallow foundation, deep foundation, 4 marks, 6 marks, done. Says, so by this you got around 11 to 12 marks. You will be ending the 11 to 12 marks. So if you see the foundation engineering, earth pressure theories plus stability of slope, we can expect 2 marks. And foundations including shallow and deep, you can expect 4 to 5 marks. 4 to 5 marks. So else you can take it as a minimum to minimum 3 to 4 marks you can expect. So how many marks over here? Total 5 to 6 marks over here from these 4 chapters. And from the soil mechanics, from these 3 chapters are 5 to 6 marks. So total 10 to 12 marks are coming from the here itself. The remaining 4 to 5 marks, you can see the remaining chapters. That's soil exploration. So you can expect, you can see. So this is as 3 to 4 marks also. Now this is 6 to 8 marks. 6 to 8 marks. There were chances where they asked 2 marks question from the earth pressure theory and 1 mark question from the stability of slopes. You see in GATE 2022, from the foundation engineering itself, they got 8 marks. From foundation engineering itself, we got 8 marks. So from these 4 chapters, 7 marks, and there was 1 mark question came from the soil exploration also. So I hope there are some 18 chapters for the GATE and 21 chapters for the ESC. So if you see, you don't need to study all those, but you need to know the overview. Even though you complete the subject, now while you are revising, you please focus on these chapters. In foundation engineering, these 4 chapters, and in the soil mechanics, these are 3 chapters. So with this, in the today's session, I discussed about what is the syllabus, and I discussed about what are the important chapters in the soil mechanics and foundation engineering, how many marks we can attain from the soil mechanics and foundation engineering, and what are the major topics that they can ask in each and every chapter. So I give you some models also. So we'll take one more session in tomorrow. Tomorrow I'll be taking what happens when flow perpendicular to the bedding planes, that's one topic. And I'll try to explain the rate of consolidation also. So 2 topics if time permits, else I'll go with the 1 topic, okay. So that's all for this session. I hope you enjoyed, and this entire 1 hour session or 1.5 hour session definitely make you helpful if you have been watching, okay. So all the best for your examination. Till then.
My name is Karthikeya Kaushik and I have secured All India Rank 1 in UPSC Engineering Services Examination 2021 from Civil Engineering discipline. For prelims preparation, I took online test series from ACE online platform and used to regularly solve their subject-wise test and full-length test. Then for mains preparation, I solved question banks which were given to me as a part of mains postal program from ACE Online. And then last but not the least, for interview preparation, I followed the interview guidance material which was given to me as a part of ACE Online's interview guidance program. Thank you. My name is Karthikeya Kaushik and I have secured All India Rank 1 in UPSC Engineering Services Examination 2021 from Civil Engineering discipline. For prelims preparation, I took online test series from ACE online platform and used to regularly solve their subject-wise test and full-length test. Then for mains preparation, I solved question banks which were given to me as a part of mains postal program from ACE Online. And then last but not the least, for interview preparation, I followed the interview guidance material which was given to me as a part of ACE Online's interview guidance program. Thank you. My name is Karthikeya Kaushik and I have secured All India Rank 1 in UPSC Engineering Services Examination 2021 from Civil Engineering discipline. For prelims preparation, I took online test series from ACE online platform and used to regularly solve their subject-wise test and full-length test. Then for mains preparation, I solved question banks which were given to me as a part of mains postal program from ACE Online. And then last but not the least, for interview preparation, I followed the interview guidance material which was given to me as a part of ACE Online's interview guidance program. Thank you. My name is Karthikeya Kaushik and I have secured All India Rank 1 in UPSC Engineering Services Examination 2021 from Civil Engineering discipline. For prelims preparation, I took online test series from ACE online platform and used to regularly solve their subject-wise test and full-length test. Then for mains preparation, I solved question banks which were given to me as a part of mains postal program from ACE Online. And then last but not the least, for interview preparation, I followed the interview guidance material which was given to me as a part of ACE Online's interview guidance program. Thank you. My name is Karthikeya Kaushik and I have secured All India Rank 1 in UPSC Engineering Services Examination 2021 from Civil Engineering discipline. For prelims preparation, I took online test series from ACE online platform and used to regularly solve their subject-wise test and full-length test. Then for mains preparation, I solved question banks which were given to me as a part of mains postal program from ACE Online. And then last but not the least, for interview preparation,